Hello, my name is Byron Serrano and I'll be presenting my final year project. It is called MechaBot. It's a educational simulation for children age range 13 to 18 to expand their knowledge on mechanical engineering and circuit boards. Here is my demonstrator.
Hello, I'm Gareth Campaverde and I am the user/tester of Byron's program.
Okay. Mr. Gareth has been helpful enough to become my tester. He's been giving me feedback and everything on my project to expand and improve it. Again, I apologize due to the presentation being in my room, as due to the COVID-19, the coronavirus, we've had to separate ourselves, and now it's due to the pandemic slowing down, we've been able to gather around and interact with each other, and this is the best opportunity to record this video. The project, the virtual reality headset I'll be using is the Oculus Rift. It'll be compatible with the touch controllers, my project. As you can see, a message will pop up saying that you need to sit down due to this project, this simulation being educational, and to do this you have to do it sitting down so you don't get any accidents due to health and safety. Okay. With Mr. Gareth, we've gone through the manual. I've written up a manual that explains obviously the controllers and the steps or the tasks that he would have to do. For this video, I'm going to talk him through it as well, just to make sure that he remembers and everything, like a simulation of if I was a teacher. Okay. As you can see, he's able to toggle on and off the tablet with his left hand. And with his right hand, he can toggle the tools that we'll be using it for this project. He has a drill and a soldering iron. Okay. Again, the tablet allows you to maneuver the robot standing on the pedestal. The pedestal pretty much allows you to holds the robot, which will be removing the circuit board away from it to fix it. Again, for task 1, we're going to have to remove the back plate to get to the circuit board. Okay, with the drill tool, you'll be able to unscrew the 4 screws located on the back of the robot. Now, once the back plate has been removed, the screws, you're able to remove the back plate and get to the circuit board. Okay, once you have the circuit board, you will teleport back to the table to complete task 1. With task 1, we would have to equip the soldering iron to remove the back plates, the soldering iron. Once the solder's been removed, you are able to remove the faulty capacitor. Okay, you place that one to the side and you grab the new working capacitor and replace it. Okay, now with the capacitor back in the circuit board, we're going to have to apply new solder on the back. And then a message will print out to the user saying that the circuit board has been completed. So moving on to task 2, you have the a blank circuit board, and this, with the TV in front, it will demonstrate the diagram of the circuit board that we'll be building, and a copy of the final look. Now you have all the equipment on the right side, the parts that will be assembled to make the circuit board. Again, once we attach the capacitor into the place, we have the switch. The switch will be added also in its place. And then we are left with the plug, which that is where that will be connected to the main socket to give the board its energy, and then the last bit will just be the motor. Once all parts are attached to the circuit board, we flip it around and apply solder onto it. Again, once the solder has been placed all into the board, it will print out a message saying the circuit board's been completed. Okay, and then from here on, we move on to task 3. Okay, for task 3, you are given again a demonstration of a circuit board. This circuit board is more realistic. This is more of based on an actual computer circuit board. So with the parts provided below, you are able to assemble an actual circuit board. You have the CPU. Okay, with the CPU, this will be the main brain of the program. This will control the circuit board. Okay, this is the north bridge. The north bridge normally controls the energy and power of the front side of the north part of the circuit board. This is the plug again. The plug is where we're gonna have the energy, the input coming in. That's just the main energy coming in to power the circuit board. Okay, that would be the RAM slot. The RAM slot again is it's the slot to add the RAM to control the speed of the computer. That's the SATA input. Again, the SATA is for the hard drive. That will just that just connects the cable. That will be the input for the hard drive. And then this is the bus slot. This is the bus slot is more designed for stuff like graphics cards. Graphics cards just help run the computer better and show better imagery and everything. Again, that's just the USB 1 and 2. They're just simple inputs for storage and information transfer. Like again, the south bridge is similar to the north bridge. It just controls the south side of the circuit board to monitor just in case anything goes wrong. That's the chip that controls that. And then last but not least, it's just a VGA cable. Again, that's more for old-fashioned outputs. Now that we're improving technology with the graphics cards, will be more HDMI, but the VGA is for the output for visual for the screen and everything. Okay, that will be the end of my simulation with the 3 tasks and everything. It just completes and outlines the concept of my project. I want to thank you for watching.